Okay, so let's start this one. So in this video, we learn how to plot the PDF and the CDF for discrete data. Right? So PDF, the notation that is common f of x, right? And the CDF is capital F of x, and it's denoted by, and remember this, is the probability that x is less than or equal to x. Yeah, once you remember this, everything else will make sense when we plot it. So capital F of x is the probability that x is less than or equal to x. So capital F1 would just be the probability x is less than or equal to 1. So it does be the sum of probabilities before 1 and 1, right? And PDF is just the, this is basically just the probability at each point. So you have the PDF and the CDF. Both are plots or graphs, as you see. So let's do it with a question. So question says given the probability of me obtaining 1, 2, 3, 4, 5, or 6 when rolling a dice is 0.1, 0.1, 0.4, 0.05, 0.05, and 0.3 respectively. Plot the PDF and the CDF. Okay, so the first thing that we'll have to do just to help us is to get the table. So we know the table have x, which is the possible outcomes, and the probability x is equal to x, which is the probability of each occurrence occurring. So the possible outcomes that we could get were given. So 1, 2, 3, 4, 5, and 6. And they also gave us the probability of each occurrence happening. So 1 was 0.1, 2 was 0.1, 3 was 0.4, 4 was 0.05, 5 was 0.05, and then 6 was 0.3. So we have a table that we could use. So now we can actually get the PDF graph. So when you plot in the PDF, it's XY axis. On the Y is the probability X is equal to X, and we'll obviously on the X is just X. X being the possible discrete outcomes. Right, but there's still discrete data. So when you're plotting it, so we have the possible outcomes 3, 4, 5, and 6. And then there's to plot it. So 1 going up to 0.1. So it's just line vertical lines like these going up to wherever it needs to go up to. 2 is 0.1 also. So now I'm looking at it. You notice it only existing at discrete points, nothing in between. Because this is discrete. And as you see, when you do continuous, so we'll have values in between the points. But since it's discrete, it only exists at the specific point. All right, so 3 is 0.4. 4 is 0.05, so that's like halfway. 5 is 0.05. And then 6 is 0.3. Should be somewhere here. All right, and with that said, that's your PDF for that data. All right. Second thing I wanted to get is the CDF. All right, so we know the CDF is capital F of x, which is basically the probability x is less than or equal to x. All right. So same xy. So the x is still the outcomes, but on the y now is the probability x is less than or equal to x. Or you can write capital F of x if you so choose. So we have the outcomes 1, 2, 3, 4, 5, and 6. So if we start at 1, it will be the probability of x being less than or equal to 1. So, which is the table. So at 1 is 0.1. And it have nothing before. So it would just be 0.1. So it would just be a horizontal line at 1, 0.1. Then we go to 2. So it'll be the probability x is less than or equal to 2. So it'll be 2 and then 1 before it. So it'll be 0.1 plus 0.1, which would be 0.2. So it'll rise up to be 0.2. Right? Then to 3, less than or equal to 3. So it'll be 0.4, 0.1, 0.1. So it'll be 0.6. Rise up to be 4, 0.05, 0.4, 0.1, 0.1. So it'll be 0.65. Running out of space. So method of x10. Let's erase this. I hope that is enough. So we have 0.65. We'll write that right here. Right. And then 5. We add an next 0.65. That'll be 0.70. And then for 6, so add up everything. It will always end at 1. Why? Because the sum of the probabilities always add up to 1. It will just be 1 forever and ever on. So, all right. And if you want to, you could connect these, and that'll be a CDF. Right? So that's basically plotting the probability of the x being less than or equal to x. And you're just rinsing and repeating it over. Yeah, and this is your CDF. So that's a recap. So at 1, let's go. Probability x is less than or equal to 1 would be 0.1, plot it. Then at 2, go again. It'll be everything before and at it. And you just keep on plotting it. It will always end at 1 because the sum of the probabilities must always add up to 1. Right? And with that said, that is your CDF and your PDF of the data set. All right, so check it in next one.